Newton's first law is that an object at rest will tend to stay at rest unless it's affected by an unbalanced force. An object in motion will tend to stay in motion unless it's affected by an unbalanced force.
The first part of Newton's law states that object at rest will stay at rest unless acted on by an unbalanced force. For example, take this water bottle. The water bottle is at rest because its forces are balanced. When balanced forces act on an object at rest, objects will not move. Both gravity and the normal force are balanced. It will stay at rest unless it's acted on by unbalanced force, like applying a force to knock it over. The second part of Newton's law states that an object in motion will stay in motion with a constant speed and direction unless acted on by unbalanced force. Take this buggy, for example. The buggy will remain to travel at the same speed and direction unless it is acted on by unbalanced force. If the buggy runs into a wall and is no longer able to travel at the same speed and direction, it changes motion.
When a net force acts on an object, the object accelerates in the direction of the net force. The acceleration is directly proportional to the net force and inversely proportional to the mass. Therefore, A equals F over M.
When dropping a tennis ball, it accelerates towards the ground. Newton's second law states that objects will accelerate in the same direction of the net force. Since the tennis ball is falling and the greatest net force is gravity, the ball will fall down because gravity is negative 9.8 meters per second squared and will accelerate towards the ground in that direction. The tennis ball will continue to accelerate until it hits the ground or reaches terminal velocity. Law states that acceleration is directly proportional to the net force and inversely proportional to the mass. Therefore, acceleration equals force divided by mass. Or, in other terms, the more force, the more an object accelerates, just like both these cars. The car with less force has less acceleration than the car that has more force applied to it. This shows acceleration is directly proportional to the mass